Hello and welcome to another Druid Summit 2022 session. My name is Peter Marshall and I'm Director of Developer Relations here at Imply. Today we're going to look at the principles of data modeling for Apache Druid. We're going to look at what they are and why they matter, and then we're going to break them down and look at examples of how they've actually been applied in a real-world data set. As this talk was created, each principle was applied to this dataset, the Chicago Taxi dataset. And in this video, I'm going to walk you through some of the scripts that I built at the time as I was applying these principles. Take a look at the code that I've put together, and of course, make any comments and point out any errors or better approaches you think I could have taken in applying each of the principles. Let's start by looking at what each of the principles are and why we should care about them. There are 6 principles. Firstly, create each table for a specific set of query shapes. Secondly, transform data as much as possible before storage. Thirdly, eliminate unused columns, and related to that, the 4th principle, filter out unnecessary rows. The 5th principle, combine rows using query time granularity, approximation, and rollup. And then finally, organize your segments for fast query execution. But why? Surely Apache Druid is powerful enough that you can just throw anything at it and it will just work marvelously. Well, when you apply these principles, every part of an Apache Druid cluster benefits. As well as making the queries that you write much simpler, on the broker you make query plans more efficient and you reduce the amount of merging that it has to do with results. On data nodes, whether that's historicals or real-time ingestion tasks, you make every segment scan worth it and you make it lean. That means that we don't have any disk access that's not required, no memory is utilised that shouldn't be, we have fewer cache evictions for no apparent reason. We don't want these processes carrying out work that really could have been done once a lot earlier, instead of many times over and over again for no good reason. Speaking of those data nodes, we can help out Druid's approximation algorithms. We can make them even faster by doing some stuff for ingestion. And we make sure that the ingestion work is adding as much value as possible. That doesn't mean just doing more work. It also means giving us ideas about how we could push certain work upstream. And as for the coordinator, we make all the effort that it and the historicals go to warming up the cluster, for example, and doing ongoing data management worthwhile. And of course, we make the best possible use of the money that we're spending. We don't store data we don't need, we don't pay for network utilization we don't need, we don't pay for cores that we don't need. So let's look again. These principles really matter. Each of them, each in a slightly different way, has an impact on the performance, resilience, and scalability of your Apache Druid deployment. And quite often, not because this is an Apache Druid thing, but because this is a shared nothing microservices design thing. So let's look at these principles, we'll uncover where to apply them, and to start with, rather like a famous science fiction movie series, we're not going to start at the beginning, we're going to start somewhere in the middle. Let's start with principle 2. Now this principle about transformation means getting the data you put into Druid as close as possible to the data you want to get out at query time. An example might be to push back a Fahrenheit to Celsius conversion. Now that function's not going to change, and what's more, users don't need to amend it in any UI that I can think of. That said, you do need to consider what flexibility your end users need in the UI around expressions, about when the result of a function is going to be settled enough that you can apply this principle. But if you do it successfully, your select statements become simpler because you can just address your calculated column. And without the expression being evaluated at query time, segment processing on the data nodes is much leaner, especially for complex expressions. So here's a little diff that shows how I've applied this principle. On the left-hand side, there's some SQL that Druid's console generated when I just pulled the Chicago Taxi dataset in using the wizard. On the right-hand side, with the principle applied, you can see I've got some as statements to give more consistent field names without spaces in them. And there are two functions, one that calculates a tips percentage, and then there's a concat to produce a point, latitude and longitude to match another field that's in the data already, the pickup centroid location that's already in the point format. If you're using the insert batch method in 24 and onwards, like the script here, you'll want to check out the SQL functions list. If you're not using insert, check out the transformations that are available at ingestion time in the Druid documentation. A call out to Helmar Becker here. His blog post has other examples of how to apply this principle when you're not using the insert statement. And this applies to key value lookups on lookup data sources too. Think about doing key value dereferencing early. There's a significant chance you'll be able to reduce overall memory usage and management cycles, let alone reducing the work that the query processing does, efficient as that is with lookups. With insert, you can do this by referencing the lookup with an extern, or with other ingestion, you could use a lookup expression or join to that table. So in MySQL, I've opted to address the lookup map using extern. In the data, two fields, which are pickup community area and drop-off community area, contain numeric keys. So I use a join on two external tables to dereference those to their string values. Now the query process is no longer need to look at that lookup, and instead it's just there to start with. If you don't use extern or you're not using insert, you'll use a lookup function. The ingestion task will then look to its own copy of the lookup to do the dereferencing. If you're not going to use that lookup anywhere else, you might want to look at information on lookup tiering in the docs, because it could help you reduce the overall memory usage of your historical processes. Now, principle 3, columns. Remember, Druid is for OLAP. It is not a data lake. Select what you need, both at ingestion time and at query time. Does a user really need 1,500 columns in this table, or is it more like 30? Think about your schema. Think about how expensive it is to store each dimension. Talk to your end users about that. Ask them if they're willing to pay the financial and performance cost of having them in their data. Using the dimension list well at ingestion time, you help Druid out, even if it is just a little bit. You get rid of the clutter in the segments with information about the columns that are superfluous. This isn't just about efficiency in the processing done by the data nodes, it's also about deep storage. It's about the work that the cluster has to do to load your data when it warms up. The storage you need on local nodes once it's been distributed and replicated. It's about network traffic. So there's a lot of things to think about here. Now, back to MySQL, you can see that I've removed columns that aren't needed for filtering or sorting or for calculations and so on. Now, interestingly, because I also set the type explicitly for the fair, we have to take care with division by 0. So also columns that are in the calculation for the centroid, they're also not needed now because we've got that information in the transform. So I've taken those out as well. It's important that you get to know also some special data types in Druid. This one is multi-value dimensions. Do again go and read this blog by Helmar Becker. So for example, maybe what I could have done upstream is to put tags around each of the taxi trips to allow better filtering and grouping. Go and have a look at this blog, it really is very cool. And new in 24.0, something very special, the ingestion of complex JSON. This feature allows you to avoid flattening, and if you do that and it creates a substantially awesome data structure, you'll find more content on that coming soon. With non-insert ingestion, take a look at this page in the docs on dimension inclusions and exclusions, including schemaless ingestion. A general note that some community members have found it's better for them to narrow the data source than to narrow it in Druid's ingestion spec for various reasons. Not just because there's a lot less data for Druid to read from the source, but also because it's proven easier for them to manage it upstream. And that applies to expressions too. Sometimes you have an expression that's easier to manage upstream. So these principles, as I said, don't just apply to the dimensions or the transforms in Apache Druid. They might also affect how you as a data engineer provide that data to Druid as well. Equally with this principle, we've talked about the width of tables. Now let's talk about the length of tables. Principle 4, about rows. This is about front-loading your where clause. If your user is looking at trips in this imaginary bus full of animals where all the tyres weren't busted, why is all this other stuff here? In 23.0 and in streaming in 24.0, you would do this using a transform expression at ingestion time. But as we heard a moment ago, consider whether it's more efficient to provide a different source to ingest from. That'll ease the burden on ingestion tasks reading data that's not needed. Apply this principle and it reduces any row-level processing that's required at query time, as well as lowering the number of rows stored within a period and thus data that the historicals and coordinators have to manage. Interesting, some users, when they've applied this principle, find that doing this increases the efficiency of secondary indexes on other columns too, because data is more localized. So back to my SQL, how did I apply this? Well, I spoke to my imaginary user and together we determined that some elements of the user interface and the way that people are going to use it mean that it's better to bucket the length of trips. You can see the round here, and they also count some trips, those that don't last longer than 5 minutes, as uninteresting. So I've where'd those out. Now, if you're not using insert like the script here, take a look at the docs to learn more about the native filters that are available to you. Now, please take a close look at this computer, one of the very first computers I ever owned with a 20 megabyte hard disk. Yes, folks, 20 megabytes. Closer, closer. Well, this is an EGA monitor. It has a resolution of 640 dots by 350 dots, and it can display 64 colours. The next principle is all about resolution and precision. Principle 5. Are you using an EGA monitor, or is it 4K? Just how many data points can you actually display? Not just on the horizontal, but on the vertical too. Principle 5 isn't just about rows, we've already covered that. This is about the group by that you will use on time charts like this, getting, say, the max trade price in a given time period. If you're doing this, creating a time chart, you really need to think about grouping early. Essentially, the principle is saying, try to move your group by back to ingestion time, as well as your where and expressions. Combining incoming rows at ingestion time means less data to be dealt with, and it also means less complicated SQL queries. Secondly, you can flex Druid's built-in group by function to enable much faster approximation within Druid. Sketches in particular can reduce the cost of storing and analysing high cardinality data. You get even faster approximate operations by creating sketches at ingestion time, or even by providing them from an upstream processor. Go and take a look at this video in the adoption playlist on Imply's YouTube channel. It'll introduce you to the approximation techniques. Take a look too at the approximation page in the documentation. Doing these two things, group by or roll up and using data sketches, impacts the stored data sizes and its representation so that all queries benefit, not just the set of queries that you're solving for with, say, hyperloglog. How does that look in SQL? Well, you can see I've got a time function now on the right-hand side. I'm flooring my timestamp to, I think it's hour. And then I've also added a load of measures. I've now loaded a load of aggregates on my measures. And I've also turned those into metrics. And I've also got aggregation functions and a group by. And that aggregation functions like sum extras to give me the fair extras total. And notice that I've also got the taxi ID and the trip ID. They're now put into sketches. So I've got hyperloglog for distinct count, so I can approximately track the number of trips and taxis. And I've got theta sketches for taxi ID, so that we can say, hey, how many individual taxis were active this week, but not last week? Principle 6 on partitioning schemes. This is all about data layout. It's about making sure that the data you've ingested is split up in a way that maximizes the efficiency of parallelization in the cluster. These data processes are extremely valuable. They are Druid's powerhouse. So you need to help the broker to use them wisely. Partitioning and data clustering technique is pivotal. A poor partitioning and clustering scheme will create a kindergarten of noisy children rather than the beauty and harmony of an orchestra. Understand and use time partitioning properly. Partitioned by or segment granularity is your first priority. Not only is it the primary partitioning level, having an impact on individual segment size and thus the time it takes for each process to return results to the broker, it's the time period in your where clause that the broker uses to determine which historical processes participate in the query. Remember to apply clustering to your data against the dimension you find in common where clauses. See if making it part of the planning that the broker does helps overall in performance, because it prunes the target segment list even further when it does its parallelization planning. Applying both of these techniques will, along with settings in the tuning config of your ingestion spec, affect segment size. They are recommendations about segment size that you can use that are in the docs, but you might find it's worth doing some experimentation, watching the metrics submitted by Druid to see what the right size is for you. Remember too that segment size and number affects the time that it takes for a given historical process to warm up on a clean start. A key tool in your arsenal on keeping segment numbers and sizes under control is compaction, whether you do that manually or you set it up using automatic compaction. In SQL, this is in two clauses: partitioned by and clustered by. If you're using native ingestion, the equivalents are query granularity and then the settings for secondary partitioning. Sergio Farragut has a series on partitioning and its effect, complete with demos, on the Druid Notebooks on Partitioning playlist on the Imply YouTube channel. And finally, Principle 1. Like every good sci-fi series, it's time to go back to the prequel. Do not be afraid of having multiple table sources, each one shaped to provide your end users with the right level of detail. You can think of this in terms of interactivity that's required, the granularity and precision that's required, and the information that's required. Now, if you're already up and live, take a sample, use re-indexing to create a new table that you can test. You can even apply principles in different ways over time by re-indexing or compacting older data back into the same table. You saw all the SQL scripts. Well, imagine how you might apply the principles to one table and leave the group by out, or maybe use a different time function that flows to day instead of month, and you'd put that into a different table or maybe re-index into the same table. Or maybe you'll keep the taxi ID in one table so people can filter by it specifically, or you can do an accurate distinct count, but then you'll have another table that is for super fast interactive stuff where you'll use the sketch for those operations. There are some other aspects to table planning in Druid as well. Take a look at this video in the Druid adoption playlist. So, we are really done this time. We heard about creating each table for a specific set of query shapes, transforming data as much as possible before storage, eliminating unused columns, filtering out unnecessary rows, combining rows using query time granularity, approximation and rollup, and organizing segments for fast queries. And you also heard about how each one of those benefits all of the processes in your cluster. Finally, I've got some cheat sheets here. Please feel free to screen grab these. This one shows the parts of the ingestion spec to focus on for each principle. And of course, with insert for batch ingestion 24.0, now you have SQL to help you apply the same things. If you want to get the down low on why this matters, I can't recommend this talk enough. This is from a gentleman called Jonathan at IronSource. This talk is the evidence that you need, if any was needed, on why you need to apply these principles and the real benefit it will have for you if you apply them into your production cluster. You can play with these principles live in the data ingestion and modeling course by Imply. Go to learn.imply.io and you can register for free. If you've got any questions about what you've seen today, do register on the community's channels, raise a question, say hello to me, say hello to Sergio, say hello to Halmar, we'll say hello to you. Visit learn.imply.io for other Druid related courses, and of course, importantly, please do with me say thank you to the developers behind Apache Druid, give them a star on the Apache Druid GitHub repo. Thanks.